Take a second to think about your friends, your family, including a few generations back. Most of you can probably picture someone that drank a little too much, a little too often. Almost half of alcoholics trying to abstain from drinking relapse within 3 months. And historically, this relapse was thought to be motivated by withdrawal symptoms, where a person would resume drinking to ease the anxiety, tremors, and general malaise of sobriety. But what about relapses that occur after withdrawal symptoms have subsided? And many do. Well, if you ask someone who's trying to abstain from drinking or someone who's relapsed, what makes you want to drink, or what made you resume drinking? They will list cues, and usually 2 different types. One type are called discrete cues. These are things like the sight, smell, or taste of a preferred alcoholic beverage, the pop of a champagne bottle, or the kss of a beer can opening. Another type are called contextual cues. These are things like a night out, being at a party, or the ambiance of your favorite bar. These discrete and contextual alcohol cues that could once be encountered unproblematically at an earlier point in the addict's life can become the difference between sobriety and relapse. So the question I asked myself in the lab is, what are the brain processes that control how people will respond to these discrete and contextual alcohol cues? I work with a rat model of alcohol seeking because rats have very similar brains to humans. But in the rat, unlike the human, I can use cutting-edge neuroscience tools to shut down specific pathways of neurons. I can do this at a time when the rat is presented with alcohol cues and observe how they respond. Do they scurry over to a dish where they used to consume alcohol or not? What I've found is that alcohol seeking to discrete and contextual cues seem to be controlled by separate neural pathways. So when I shut down one of these pathways, I reduce alcohol seeking, but only to the corresponding cue. These fundamental studies will help identify targets for pharmaceutical intervention in humans, and that's the ultimate goal. If we can understand the neuroscience of what motivates a rat to pursue alcohol, then perhaps we can prevent a person, someone who really wants to stop drinking, maybe that person you imagined at the beginning of the talk, from relapsing. Thanks.